Hey everyone, welcome to this AZ400 lab on monitoring application performance with Azure load testing. So, like any other lab, we do have some lab prerequisites which might be a little bit different in your scenario depending on the lab hosting environment you're using. Maybe you're using your own subscription, but just to set it up correctly, let me quickly share some of the lab prerequisites, just making sure that you might validate it on your end as well, checking if you do have the DevOps project set up correctly, that you import the sample GitHub repo into your Azure DevOps environment, and also having your Azure subscription service connection up and running. So to start it off, I do have my DevOps organization, and within created a new project called eShop on Web. Next step, according the overall Azure 400 course lab instructions, is importing the eShop on Web sample project, sample repository from GitHub, and it should look a little bit like this. Now, since this has been used for quite a while already, one of the recommendations we have is navigating to your repo branches, selecting the main branch, and from there flagging it as the default. That's making it a lot easier once you start reusing some of the repo artifacts in source control or some other labs if you're working on those ones. Next, we need an Azure subscription, and we also need a DevOps service connection, allowing you to actually integrate with your Azure environment. You can manage that through project settings, navigate to service connections, and from there you're going to create a new one. Obviously, to speed up the demo a little bit, I already have one, but the steps are the following. So you go to New Service Connection, select Azure Resource Manager, click Next, and you do have a few options where the recommended one nowadays is using Workload Identity Federation, where in the back of the Azure platform, it's creating an app registration service principal together with some credentials, but all happening magically behind the scenes, where again, the fallback scenario, if in your specific setup, you would not be able to use that, could be the traditional service principal, where it's going to ask you for connection name, your subscription. So you might need to provide your Azure subscription details here, and then making sure that obviously you save that as well. So if you do have your Azure subscription ready, if you have the service connection, if you have the repos, and I would say it's about time to jump into this actual lab where we do have a few objectives. So the first one is actually a little bit happening in Azure itself, deploying Azure App Service web applications, where next you're going to create a YAML CI/CD pipeline. Once we have our sample retail web application up and running in Azure, that's where we're going to move to the actual core of this lab, deploying Azure load testing, integrating load testing for the published web application, and from there eventually running the last exercise, and that involves running Azure load testing from within CI/CD pipelines. If you're following along in the lab instructions, we're starting with task 4, since the other tasks were mainly the lab prerequisites. But again, depending a bit on the lab scenario you have, you might already have everything in place. So the first step here involves creating Azure resources. So to help you a bit with that, we offer you some sample Azure CLI scripting options, and we're going to run these from within our Azure Cloud Shell. If you never used Cloud Shell before, it's like an Azure command line interface integrated in the Azure portal, allowing you to use Bash like a Linux-based command line interface, PowerShell, where in our case, we're going to use the Bash version of it. So the first few steps here is creating a new resource group, defining the location for the resource group, And then next we're going to create an app service plan and the actual Azure app web app service. So using the sample code from the lab instructions, it looks a little bit like this. So what we're doing here is creating the resource group name, AZ400, where now I need to define the location. Depending a bit on the setup of your lab Azure subscription, this might be different, so make sure you follow the instructions based on the lab hosting scenario, where in my case I'm going to use Central US, but I would say pick any available region where you do not have any limitations. And then the core of this task is running AZ group create a new Azure resource group using the name and location variables or parameters that we defined earlier. So in just a split second, it's already done, which means we can now move on with the next step. And it is roughly the same idea. So we define a service plan name parameter variable, AZ400 lab 14 SP, and then we're going to trigger AZ app service plan create, which means create me a new application service plan, and store it inside that resource group and provide a name. And we're going to use a specific app service plan, like the cost and performance model behind it, where in the lab setup we use a B3 plan because we don't need a lot of performance. So it created our app service plan, which now means we're ready for the last step, and that involves the creation of the actual Azure web app itself, where again we define a web app name, parameter setting AZ400 eShop on web with some additional random unique strings, and then launching the Azure CLI command AZ web app create the web app using the resource group, the plan, and the name that we already defined earlier. So that's, I would say, everything we need from exercise 0. So we had a few prerequisite steps: the project, the repo, the service connection, and then the last task was creating the Azure resources. With all that almost done, I'll just give it another second. Allowing the resource group and the web app being created. So I can navigate to my resource group, and from here you can see I got my app service plan, and after a little refresh it will show me my web app as well. It now means that we are ready to go with our next exercise, actually the first one here, and that's using or configuring CI/CD pipelines to deploy our Azure eShop on web retail example web app scenario into our Azure web apps. So to do that, we're going to create a new pipeline where it's going to ask where is the code, selecting Azure repos, selecting the eShop on web repo we have, and from here we're going to use a starter pipeline. Why are we using starter pipeline? Because out of the lab instructions we already have sample YAML syntax. So I'm going to grab everything from that sample and literally copy pasting. And to help you a little bit understanding like what's actually happening, let me spend a couple of seconds here inside that sample YAML pipeline. So the first part here, resources, I would say emphasizing trigger none means that there's no full CI or CD yet. It's not automatically running the pipeline, that's what it means. Trigger none actually defines that it is a manual triggered pipeline, meaning the DevOps engineer has to push the button to actually run it. Next, we define stages, where the first stage over here is called build, and what we're doing there is running the CI part, continuous integration, pointing towards the Azure DevOps build agent, in this case an Ubuntu version where we're using the latest 24, and we're running .NET sample code, which means we have, I would call them the traditional .NET restore.NET build.NET publish. So that's what you would use, even almost manual, on your Visual Studio VS Code on your local machine running some .NET Core command line, .NET restore, .NET build, .NET publish. Once all that is done, we move over to the last step in a typical build pipeline, and that's publishing the artifacts, which means we have the code compile state done, and we're going to move that into our artifact staging location. Where now, since we have a publish artifact task, once we want to move to deployment, like the CD part, continuous deployment part, it means that now we have to start from that artifact. And that's what we're doing here in deployment stage, and we're using download build artifact. So almost, I would say, at least in a .NET scenario, is running the .NET Core compile, restore, build, publish, and then last creating that web deploy zip package, uploading it into the artifacts location. And then the first step in the actual deploy is, at least for now, the download build artifact, like making it available to the pipeline. Now, our pipeline is not 100% finished yet because we're missing an actual step in our stage deploy, meaning grab the code that's done, but now handing it over to the actual Azure App Service. Now, to show you a nice integration we have between YAML, like pipeline as code, and the older DevOps, Azure DevOps Classic scenario, is what we can do here, making sure that your YAML indentation is correct, which means I'm going to add a new task, and to make sure that syntax-wise it's all running fine, I got to make sure that my cursor is at the correct position next to the previous aligned task. Now, to show you that integration between classic graphical pipelines, a little bit from the past, and our new pipeline as code, it's happening over here where you can use the assistant. So what I'm going to do here is opening the graphical interface and searching for Azure App Service. And that's allowing me to reuse a classic task from the past, where now I can still use some of the graphical interface mindset, and that's eventually going to move it into YAML syntax. So to do that, we need to complete a few parameter settings from the graphical interface. I'm connecting to Azure Resource Manager. I'm going to use my connection, which means pick up the service connection we created, or that you have already available in your lab environment. We need to define the application in Azure, where we go for the Azure web app, and got to make sure this is web app on Windows, and that's resolving our AZ400 eShop Azure app service that we created at the start of the lab using our CLI command. We're almost there, but we need to highlight the actual web application artifact, right? Now you can see here that it's picking up anything that looks and feels like a zip web deploy zip package. Now we have to make a minor change here. Instead of allowing star.zip, we need to use web.zip. The reason why, and this is specific to our sample application, is that we do have the web front end, like the retail application that a customer would use, right? But we also have an admin web application, which hypothetically would be used by the web admin owners. So instead of allowing the deployment of web.zip and admin.zip, because you can only deploy one zip file at a time, it means that we have to specifically identify to use the web zip. And then last, but again, it's quite specific to our lab example, is adding application and configuration settings. What this allows us to do here is adding web application Azure App Service environment variables, specific configuration settings, where we're going to define two parameters that our application needs. The first one is use I'm gonna paste them in here from the lab instructions. Use only in memory database, which means that we don't need to connect to like a SQL database or something similar in the web application that we have. And we're also gonna define the ASP.NET Core environment as being development, meaning that it's not 100% production, right? Now, when I add all these steps in, it's now nicely moving this into YAML syntax. So that's pretty much everything we needed from here. And then we're gonna save our pipeline. I'm not gonna run it yet because there's another little step I wanna show you. Because right now we do have our pipelines. And as you can see in the runs, we don't have anything because we didn't run the pipeline yet. Now, if I take one little step back, it's going to show me that the name of my pipeline is just called eShop on Web, which obviously is not always that clear. And from here, you can go back, edit the pipeline, and that's still literally the one we need. So what we're going to do here is renaming. Now you can see from here, there's not that many options. So what we need to do is take one little step back. And then from here in the list of pipelines, we can actually select rename or move, like moving it into a subfolder. Because since we're using pipelines as code, all of our pipeline YAML files will be stored as part of source control. So we're going to rename this one here to, for example, AM08 Lab 14, pointing at our DevOps lab order, and giving it some descriptive name. So this could basically be almost anything that you want. Well, now it's about time to actually run the pipeline. So we're going to kick it off and giving it a couple of minutes. Now remember, in our definition, we had two different pipeline stages, one for build, one for deploy, meaning grab the code, test it, compile it. And once the build stage is successfully done, we're going to move it to the deploy. And that means grab the code and push it into the Azure App Service. This is going to take a couple of minutes. So I would say from here, just for the sake of the demo recording, I'm going to speed it up a little bit and skipping the actual waiting time or the processing time that it needs. So I'll see you back in a bit. All right. So with that, we do have our successful CI/CD pipeline. Now, because as you could see, it took about 5 minutes. I obviously removed that part from the recording, but to help you a bit understanding what actually going on within each and every stage, I can walk you a bit through the details. So in our CI part, remember, we have the .NET source code being picked up. That's what the checkout step here is doing. Next, we executed 3 .NET Core command line steps: .NET Restore, .NET Build, .NET Publish. And from there, we're executing the publish artifact. So grab that web.zip package and store it in the artifact temporary build location. And then in the second stage of the pipeline, the actual deployment, again running the checkout, from there downloading the build artifact, like connect to the build directory, grab that zip file, and running the Azure web app deployment. And then as you can see here, we do have quite some verbose monitoring and logging inside each and every of those steps. Ultimately, after running a successful CI/CD pipeline, we would navigate to our Azure resource where the app service itself is up and running and allowing us to connect to the web app URL. And eventually we have our application up and running. Pretty cool. Because what we can do from here is now moving on to exercise 2 in this lab, and that's deploying and setting up Azure load testing. So to do that, we go back to our Azure portal, and from there, we're going to create a new resource. The resource is called Azure Load Testing. Where we need to provide some details, just like any other traditional Azure service. By the way, I don't need my Cloud Shell anymore, so I'm going to close this for now to make it a little bit easier for you to follow along what's actually happening. So we have our subscription. The resource group can be a different one, but I'm going to use the same one where I'm running the resource, but again, it doesn't need to be the exact same one. My Azure load testing instance will be called eShop on web load testing. And we're going to define a region, which could be any region, but I'm going to use East US because that's where my actual web app service is running. As you can see here, there's some validation about the naming. So I could call this eShop on web load testing lab or something, and that would be accepted. That's pretty much all we need to get our service up and running. Name doesn't need, seems to be unique. But once we're past the validation, it's just going to take a couple of minutes before the service is up and running. So the Azure load testing got created, and we can now move on and validate the actual resource. So what we're going to do now is obviously creating the Azure load testing test in our task 2 of the lab. So from within the eShop on web load testing 1, 2, 3, we're going to navigate to tests and creating a new test. Now there's a few different options. We're going to use HTTP. Why? Because we're obviously testing against a web application. So it's going to ask for our test URL. We navigate back to our original eShop URL, and we're going to provide that a little bit later on in our parameters here. So the test name could be, like as you can see by default, it's the date and the time. You could rename this. I'm just going to accept all the defaults. And we're going to add a new request where my request name is, for example, request1 HTTP, and we're going to provide the full link to our website. For now, we're going to run the get HTTP method, but as you can imagine, you can trigger some other load testing, like uploading files would be like a put, making changes, a post or delete action, or anything else that you want to validate. But for now, our test will simulate like users actually connecting to the web workload. That's where we define or have the option at least to define some additional parameters, like for example, changing environment variables, connect to a different database, not production, but like dev and test, for example, integrating secrets if you need credentials to connect to resources, to authenticate, to interconnect with other secret parameters that you might need to inject. Like you can tune quite a lot of this. For now, the main thing here is in the load tab where we specify what is the load simulation we want to trigger. I'm going to accept all the defaults, number of virtual users, 50 concurrent users. I'm not going to run the test for 20 minutes. I'm going to run it for 5 minutes. And the ramp up time is 1 minute, which means we're gradually adding users into the load testing up to the maximum of 50 in our parameter definition, instead of like from the first second already having 50 users, because that's, I would say, a little bit closer to what a real life scenario could look like. So from here, it's creating the Apache JMeter. That's the framework we're using behind the scenes. It's creating the load testing file, and then after a couple of seconds, it's actually presenting the test, and that would allow us to literally run the test as well. Now we do have one test, but if you're following the different instructions in the lab environment, you're going to see that we actually do have a second test. So we're going to create a new URL-based test. I'm going to keep all the defaults. I'm going to paste in my website URL once more. But then the minor change here is in the load, where this time we're using some larger numbers. And you can immediately see here something I didn't show you before, but you can see that up here. You can immediately see the impact. If you move this up, maybe move this down, that would be the flexibility you have. Now this time we're not using a load like the 50 users we had before, but we're moving to specific test criteria. What we're doing now is adding requests per second, where we're going to use an average, and the condition, for example, could be greater than, less than. And we're defining some thresholds where up here we're going to define like a threshold of 500. All other settings will remain the same. From here we go into our test definition and we're going to run it. Now again, as you know, we specified a runtime of 5 minutes, which means we're going to have to wait a little bit before our test is complete. So for the sake of the demo recording, I'm going to pause for a little bit and coming back once the test has been successfully completed. So after giving it a couple of minutes, you can see here my test is still running, but it's close to finishing. So once your test has been running, you can actually get access to a pretty complete dashboard. So what you can see here is, for example, obviously the parameters that you used for the testing, but then also the impact of the users. So remember, we specified gradual growth, and then from there it's running the simulation with 50 simultaneous users. Now during that lifespan of, and I know 5 minutes isn't really impressive, right? But what we can see here is that we do have some initial impact at first, like there's a little spike on response time, meaning it's slowing down the system, but then eventually it's actually catching up, and that's thanks to our app service plan. Now this is all happening within the Azure portal. So now we're going to move over to task number 3 in the lab and actually, or exercise 3, I would say, actually automating load testing within CI/CD pipelines. So to do that, we can actually reuse quite some of the settings that we already have in our pipelines. Now to make sure that everything is fine on the DevOps side, remember during the initial lab onboarding, we wanted you to create that service connection. So we're going to reuse that service connection to make sure that we have enough interaction with Azure. Now to make sure that we are also integrating role-based access control, we would actually need to make some minor changes in our service connection itself. Which means we go into our DevOps environment, we go to project settings, selecting the service connection. And from here, we can actually make some changes. Now from here, as you can see, we didn't specify any specific resource group. We just have our subscription, which now means that we have to go back to our Azure portal. And we're going to select Manage Service Roles. This is redirecting us to the actual Azure portal and showing us our specific subscription. So what we need to do here is adding a specific role permission for our load testing. So we're inside our subscription level where we do have our subscription up and running. So what we're going to do is adding a new role assignment. We're going to search for load test, where for now we could define load test contributor. That would allow us to actually run some testing, validating some of the tests that, for example, someone else already specified, where we're going to select user groups, service principals, selecting members, and searching for our eShop on web service principal that we created earlier. With the permission correctly set up, we can go back to our DevOps environment, where now we need to make some changes to our DevOps pipelines. Now, the nice thing is that inside our load testing, where before everything was nicely running from within the portal, we can now download our input files that's going to create the JMeter, and we actually can reuse those files and handing them over as part of the pipeline. Now, to make sure we get access to the files, so we're downloading our input artifacts, and I'm just going to copy this on the side. And then making some changes in our pipeline. To hand over the files in our pipelines, we first going to upload them as part of the repos. Now I'm going to do this from within the Azure DevOps portal. Obviously, if you do have a full source control scenario in place, you would probably do this from within your local machine, and then from there running a commit task, synchronizing it up into your repository. But just showing you a different way of how to interact with your repos, although in a real life scenario, you most probably would not do this from within the DevOps portal itself. So to upload files, it's a little bit tricky, I would say. We would go into repos. We already have a test subfolder. And since we're running a new test, although it's not really a functional integration, we would create a new folder here, and we're going to call the folder JMeter. Now we cannot create a new folder without a new name or a new file. So we need to create some file here, and I'm going to call it the placeholder text file. Within the JMeter file, we can now select upload files. So again, we're not really using the placeholder file itself. We're going to browse to our downloaded files, and we're going to grab the config YAML and the URL test GMX. That's the file we actually need. And we uploaded them successfully into our repos. We're now one of the, I would say, last tasks apart from running the pipeline is now updating our existing CI/CD workflow YAML definition file. Now, to create and run the load test, we actually need to add the Azure load testing extension, which means we first have to navigate to marketplace.visualstudio.com and searching for Azure load testing. From here, you would select Get It Free, and that's going to allow you to import it as part of your DevOps organization. With that import being out of the way, we're now navigating to pipelines, selecting our existing pipeline that we created earlier. And here on the side, we can now search for Azure load testing. About similar to our web app scenario from before, we just need to complete some of the settings where we're going to do. So here we define some of the details related to our Azure load testing. So it means defining our subscription, the load test file, where I just copied the path from the actual repository location, right? Make sure you select config.yaml, the resource group where my load test is running, the load test resource itself, where we defined eShop on web load testing with some unique name, the load test run name, which again can be copied from our testing scenario. Some description if you want, which could be something like load testing from Azure DevOps. And we're going to add that as a nice task inside our YAML pipeline. Now we're almost done. One additional little step we have to add here is adding a new snippet for the publish task, which allows us to actually show the results of the Azure load testing task during the pipeline run. So I'm going to copy these steps. And from here, we're actually running our pipeline itself. So with all those steps defined and running our actual pipeline once more, you can see that our step here, Azure load test, is now successfully running. And it's about the same what you can see down here, validating test plan. And if you want, we can actually go back to our Azure portal to view the load test run in progress. So that means we do have a successful run of the pipeline, triggering our load testing out of the pipeline itself. So with that, we're basically at the end of this lab scenario, where the main goal was helping you understanding how to, first of all, deploy a web app into Azure using Azure pipelines, as well as deploying Azure load testing resource using the different test runs. Initially from a manual perspective, and then gradually moving into an integration of the JMeter load testing config YAML file into our Azure repos source control, updating or extending, if you want, our CI/CD pipeline with Azure load testing. And then in the last exercise, you learned how to define the success criteria of that exact same load test. Thank you for watching.